Hello everyone. So the next topic which we will be discussing here is about the activation energy. So activation energy, it is the extra energy which is given to get useful work done. So in chemistry, we call it the minimum amount of the energy needed to activate or energize the molecules or atoms to undergo a chemical reaction or the transformation. So let's discuss it further. That activation energy, it is defined as the minimum amount of extra energy required by reacting the molecules, and it will get converted into the product. So it can also be described as the minimum amount of energy which is needed to activate or energize the molecules or atom so that they undergo a chemical reaction or the transformation process. Now, what is the SI unit of activation energy? So first of all, the activation energy is denoted by this symbol, that is EA, and it is usually measured in joules and or kilojoules per mole or kilocalories per mole. So this is how the SI unit of the activation energy can be written. Now there are few factors also which is affecting the activation energy. So the first factor is the nature of the reactants, and the second factor is about the effect of catalyst. So what are these? So nature of the reactants. In case, if we take in case of a ionic reactant, the value of the EA will be low because there is an attraction between the reacting species. While in the case of covalent reactants, so when there are covalent reactants present, the value of EA will be higher because here the energy is being required to break the older bond. So that is why there is an ionic reactant in which the energy is EA is low, and there is a covalent one in which the energy is very high because energy it is required to break the bonds, older bonds. The next is about the effect of catalyst. So catalyst, it can be positive and it can be negative. Okay, so positive catalyst provides such an alternate path in which the value of EA will be low. So it will provide such an alternative path so that the value of EA will be low, while the negative catalyst provide such an alternative path in which the EA will be high. So this is the, for example, if I have to plot a graph for the effect of catalyst, then how this graph is plotted? So this graph is plotted in this way. So this yellow line is the negative one and this is the positive one. So in this way the graph is represented. Now activation energy does not depend upon the temperature, pressure, volume, concentration or coefficients of the reactants. The activation examples of the activation energy includes the exothermic reaction and the endothermic reaction. So what is happening is, so first we will be discussing about the exothermic reaction and afterwards we will be discussing about the endothermic reaction. Now, this is a graph which is representing the exothermic reaction. So here the activation energy for the forward reaction is EAF. Okay, and the activation energy for forward reaction is EAB. So EAF is more than EF. So in this way it is being represented. Now exothermic reaction, it is a chemical reaction that involves the release of energy in the form of heat or light. So exothermic, in which the heat or light is being released in the form of the energy. So exothermic reaction, here the energy is transferred into the surroundings rather than taking energy from the surroundings. So this is the case of the exothermic reaction. So next comes is the endothermic reaction. So this is a graph which is representing the endothermic reaction. So here you can see there is a activated complex. There are few measurements. So the graph, it is being plotted between the process of the reaction and the energy. So in case of endothermic chemical reaction, the release of the energy is in the positive value. So delta H is equals to positive. So we can see that the reactant, which has 20 kilojoules of energy, and it needs 40 kilojoules of extra energy for breaking the bonds. So the energy released during the bond formation is less than ER. So here, if I have to plot a formula, then delta H is the enthalpy of the product. It is the enthalpy of the product minus the enthalpy of the reactant. So this is the formula for the endothermic reactions. Next comes the activation energy formula. So this formula can be represented as K, which is the rate constant, equals to A, that is the Arrhenius constant, minus EA, that is the activation energy. In the first slide I have told you that this denotes the activation energy, which is being divided by R, that is the gas constant, and T. So this is how it is being represented. So this is in the upper form. So it can be written like this: K equals to AE minus EA by RT. So it is in the power form. So it is not written here, so it is in the power form. So this was about the activation energy formula. So this was all about it. These are some of the references. Thank you.